The Sahara is the largest desert in the world, 4 times larger than the Mediterranean, almost as large as China. A sea of sand, rock, and heat extending from the Atlantic coasts of Mauritania to the Red Sea, from the Libyan Mediterranean to the Sahelian states of sub-Saharan Africa. It is the most inhospitable place in Africa and one of the most inhospitable on the planet, with average rainfall of less than 25 millimeters per year across most of its extent, with temperatures reaching 57 degrees Celsius at the soil surface, with winds that raise sandstorms that can darken the sun for days and bury under meters of dust anything that dares to stand still. There is also something that is often overlooked when speaking about the Green Sahara from a personal perspective: the absolute normality with which that world existed. The herders who drove their cattle from one lake to another in the Sahara of 8,000 years ago did not know they were living through a period of climatic exception. For them, that green world was simply the world, the only one they knew, the only one their parents and grandparents had taught them to know. And when that world began to disappear, first slowly and then faster, their descendants also could not know that what they were seeing was the end of an extraordinary 10-millennium period. They only saw that this year's lake was a little smaller than last year's. The Sahara we see today is the tomb of a world. Beneath its sands are rivers that do not flow, lakes that do not reflect the sky, and the traces of the lives of thousands of human beings who lived, loved, raised children, and died in a place that today would kill anyone who tried it without preparation. That superposition of worlds is one of the most powerful metaphors that geology offers about the impermanence of the conditions we take as permanent. Tonight, as we explore the history of the Green Sahara, we are also exploring a fundamental truth about the relationship between humans and their environment, that the conditions we call home are always historically contingent, always the product of forces larger than ourselves, always temporary on the scale of the earth that sustains us. The people of the Green Sahara built their lives on what seemed like solid ground. The desert that replaced their world has itself been replaced before, and will be replaced again. Everything that seems permanent is permanent only in the way that a lake is permanent, for exactly as long as the conditions that created it continue to exist. What is perhaps most striking about the Green Sahara from a human perspective is not its existence but its end. The paleoclimatic record suggests the transition from green to desert in many parts of the Sahara took less than 2 or 3 centuries. For a population of herders whose planning horizon extended perhaps a generation or two, that is fast enough to be experienced as catastrophe, slow enough to be survivable by those who read the signs and moved in time. The people who left have descendants today. The people who stayed too long do not. The history of the Green Sahara is also a history of scale. The forces that created it, the orbital mechanics of the solar system, operate at timescales of tens of thousands of years. The monsoon system that responded to those orbital changes operates at seasonal and annual timescales. The vegetation that responded to the monsoon changes operates at decadal timescales. And the human populations that responded to the vegetation changes operated at generational timescales. The Green Sahara is a story about how forces operating at completely different scales interact to produce the world we experience at the scale of a human life. The recovery of that lost history, made possible by the modern science of paleoclimatology and desert archaeology, is itself a notable achievement. Barely 50 years ago, the African Humid Period was known only in general outline. Today we can say with considerable detail what the Sahara was like 8,000 years ago, which animals lived in it, what type of vegetation covered it, which rivers crossed it, which populations inhabited it, and how those populations lived, organized themselves, and represented their world on the cave walls. That reconstruction, assembled from scattered fragments of evidence gathered by decades of patient research, is the way science gives language back to the worlds that could not speak for themselves. It is difficult to imagine that this same place was, just 10,000 years ago, a green savanna. Not a green savanna in some marginal zone, in some small oasis that miraculously survived the heat. A green savanna covering almost its entire current extent, with permanent rivers flowing through valleys that today are dry basins of bare rock, with freshwater lakes that in some cases had the dimensions of small inland seas, with acacia forests and riverside trees along the banks of those rivers and lakes, with hippopotamuses, crocodiles, giraffes, elephants, and lions living in what is today one of the least habitable surfaces on Earth, and with human beings, thousands of them, fishing in those lakes, herding their livestock across those grasslands, and leaving rock paintings on stone walls we can still see today, images of animals and people that speak to us of a world that disappeared before any historical civilization existed to remember it. That world has a scientific name, the African Humid Period. It began approximately 11,000 years ago, when the end of the last ice age reorganized the planet's climate patterns, and ended approximately 5,000 years ago, when those same climate patterns changed again and the desert returned. In human terms, it lasts as long as all of the history of the historical civilizations of Mesopotamia, Egypt, and China combined. In geological terms, it is a blink. And what makes the story of the Green Sahara especially fascinating is not only that it existed, but the speed at which it ended. Paleoclimatic studies of recent years suggest that the transition from the Green Sahara to the arid Sahara we know today was not gradual but abrupt. That within the space of a few centuries, perhaps fewer than 2 or 3, the entire ecosystem collapsed. The lakes dried. The rivers disappeared. The vegetation died. And the human beings living there had to choose between dying and leaving. The impermanence that the story of the Green Sahara illustrates is not exclusive to deserts or to remote eras, but a fundamental characteristic of all the complex systems of the Earth, which in geological scale are always in transition between one state and another. What we call climatic stability is always a relative stability, a condition that persists long enough for the civilizations depending on it to believe it is permanent. The story of the Green Sahara reminds us that that belief, though understandable and perhaps psychologically necessary to organize a life, is always provisional from the perspective of geological time. Tonight we explore that story. The story of the world that existed before the desert, of how that world was possible, of why it ended in such a dramatic and rapid way, and of what happened to the human beings who inhabited it when the desert returned. To understand why the Sahara was green, one must understand how the Earth's climate functions at the scale of thousands of years. The Earth does not move around the Sun in a perfectly stable orbit. The shape of that orbit varies slowly over time, oscillating between a more circular and a more elliptical orbit in cycles of approximately 100,000 years. The Earth's rotation axis, the imaginary axis around which the planet rotates once a day, also does not always point in the same direction. It describes a slow precession movement, like that of a wobbling spinning top, with a period of approximately 26,000 years. And the inclination of that axis with respect to the plane of the Earth's orbit also varies slightly, between 21 and 24 degrees, in cycles of 41,000 years. The positive feedbacks that amplified the initial change are particularly important for understanding the magnitude of the transformation. When the monsoon rains begin penetrating further north, the vegetation those rains sustain grows where nothing had existed before. And that vegetation changes the properties of the surface. Instead of the bare sand that reflects most solar radiation back to space, the vegetation absorbs that radiation and converts it into heat and evapotranspiration, which humidifies the air and favors cloud formation, which produces more rain. It is a self-reinforcing feedback cycle. More rain produces more vegetation, which produces more local humidity, which produces more rain. The climate models that have tried to reproduce the transition from the Green Sahara to the arid Sahara have had to include those vegetation climate feedbacks to reproduce the observed speed of change. When the models only include the orbital forcing, they produce gradual transitions that do not match what the sedimentary records show. When they include the vegetation albedo rainfall feedback, they produce more abrupt transitions that closely resemble what the data indicates. The science of paleoclimatology that has revealed the Green Sahara is also one of the most collaborative and internationally connected disciplines in science. The data that reconstructs the African Humid Period comes from sediment cores drilled in African lakes, corals sampled in the Atlantic and Indian Oceans, ice cores drilled in Greenland and Antarctica, stalagmites from caves across North Africa and the Middle East, and the instruments of orbiting satellites. Each of those data sources contributes a different piece of the puzzle, and the synthesis of all of them into a coherent picture of what the climate of the Sahara was doing 10,000 years ago is one of the great achievements of modern Earth science. The mathematics of the Milankovitch cycles also predicts the timing of future African humid periods, assuming no other climatic forcing intervenes. The next orbital configuration favorable for an intensified African monsoon will occur approximately 15,000 years from now, when the precession cycle will again place the Earth closest to the Sun during Northern Hemisphere summer. Whether that future humid period will be as extensive as the one we are discussing depends on the state of the global climate at that time, including the effects of any long-term changes in greenhouse gas concentrations. Those three variations in the geometry of the Earth's orbit, the shape of the orbit, the direction of the axis, and the inclination of the axis, act together to produce the complex rhythm of the ice ages and the warm periods that have characterized the Earth's climate for the last 2.5 million years. The African humid period occurred during a specific configuration of those three cycles that favored the intensification of the African monsoon, the precession placing the Earth closest to the Sun during Northern Hemisphere summer, when the monsoon is active and the continent is being warmed. As that configuration changed, so did the monsoon, and so did the Sahara. Those three variations in the geometry of the Earth's orbit, known as Milankovitch cycles in honor of the Serbian mathematician Milutin Milanković, who calculated them in the early 20th century, have direct consequences on the Earth's climate because they determine how much solar energy each region of the planet receives in each season of the year. The Milankovitch cycles also have consequences for the future of the Arctic and Antarctic climate. The gradual reduction of summer insolation in the Northern Hemisphere that has been producing the Saharan aridification for 6,000 years should also, in the absence of other forces, be slowly initiating the next glacial period. That it is not doing so, that instead the planet is warming at a speed unprecedented in the paleoclimatic record, is the most direct signal that human greenhouse gas emissions are overriding the natural climate forcing of the Milankovitch cycles. The fundamental climate engine of tropical and subtropical Africa is the African monsoon. The monsoon is the wind system that in summer brings moist air from the Atlantic and the Indian Ocean into the continental interior, producing the rains that sustain the savannas and tropical forests of Africa. The intensity of that monsoon depends fundamentally on the temperature difference between the African continent and the surrounding oceans. The greater that difference, the more intense the attraction of moist oceanic air toward the continental interior and the more rainfall the monsoon produces. 11,000 years ago, the precession of the Earth's axis made Northern Hemisphere summers significantly hotter than they are today, with up to 4 or 5% more solar radiation received during the summer months. That warmed the African continent more than it warms today, amplifying the temperature difference between the continent and the surrounding oceans, and therefore intensifying the African monsoon. The summer rains penetrated much further north than they do today, reaching regions that are now arid or hyper-arid. That greater northward penetration of the monsoon is the fundamental cause of the African humid period. It was not a radical change in how the climate functions. It was the intensification of a climate system that already existed, produced by slow but significant astronomical variations in the geometry of the Earth's orbit. A small change in the amount of solar energy received in summer, amplified by the feedback mechanisms of the climate system, was sufficient to transform the Sahara from desert to savanna. The Green Sahara was not a uniform reality across its full extent or throughout the entire African humid period. It was a mosaic of ecosystems varying according to latitude, altitude, proximity to the coasts, and local geological characteristics. The Central Saharan mountain massifs, the Hoggar in Algeria, the Tibesti in Chad, the Air in Niger, functioned during the African Humid Period as islands of humidity that received more rain than the surrounding plains and fed rivers that flowed toward those plains. In those mountains, the evidence of the ancient humidity is especially clear. Valleys excavated by permanent watercourses, lake beds with the fossils of the aquatic organisms that lived in them, and rock paintings representing the fauna of the moist savannas. Those mountain ranges were the last refuges of humidity as the Sahara dried, the places where the rivers flowed longest and where the last communities persisted before abandoning the desert interior. The Megachad Basin is visible in the modern Sahelian landscape as a series of fossil shorelines etched into hillsides hundreds of kilometers from the current lake. The distance between the current Lake Chad and the ancient Megachad shorelines can reach 300 kilometers in some directions, representing 5,000 years of lake shrinkage. A change of that magnitude transforms the entire human geography of a region, forcing migrations that cascade through cultures for generations. The ancient rivers of the Green Sahara also carved the geology of the Sahara in ways that are still visible today. The Great Canyon systems of the Central Sahara, including the dramatic gorges of the Ennedi Plateau in Chad and the Akakuz Mountains in Libya, were carved by rivers that flowed with a force that the occasional flash floods of the modern desert cannot approach. Those canyons, now silent and dry except after rare rainstorms, are monuments to the hydrological power of the Green Sahara, carved by rivers that carried the runoff of an entire continent for thousands of years. The pollen records preserved in the lake sediments of the Green Sahara also tell us about the seasons. Which plants flowered in spring, which in summer, what the rhythms of the vegetation were across the year. Those seasonal records, embedded in the annual layers of lake sediment, connect the big story of the African Humid Period to the granular reality of individual years. The wet season when the rains came and the grass grew tall, the dry season when the lakes shrank and the herds gathered around the permanent water. The cycle of abundance and constraint that organized life in the Green Sahara just as the seasons organize life everywhere. The evidence of that ancient Saharan hydrology is also visible in the underground drainage systems. Beneath the sands of the current Sahara exist enormous fossil water aquifers, water that accumulated in the porous subsurface sediments during the African Humid Period and that has since remained trapped there, without recharge, because the rains that filled them have disappeared. That fossil water, from which some Sahelian countries today extract millions of cubic meters for irrigation and human consumption, is a direct legacy of the Green Sahara, a millennial water reserve being depleted without possibility of renewal under current climate conditions. Every drop extracted from those aquifers today is ancient rainwater, 8 or 10,000 years old, that fell during the monsoon seasons of the Green Sahara and has been waiting underground ever since. The most southerly regions of the current Sahara, those that today border the Sahel, experienced during the African Humid Period conditions similar to those of the moist savannas that exist further south today. Tall grasses, acacia trees, and gallery forest along rivers would have dominated those landscapes, with the fauna that accompanies those ecosystems in Africa. Elephants, giraffes, buffalo, lions, leopards, cheetahs. The difference from today was not only in the vegetation and fauna but also in the availability of water. Permanent rivers that today are dry wadis, seasonally filled basins that today are waterless rock depressions, and a higher water table that made groundwater closer to the surface and more accessible. Lake Chad is perhaps the most dramatic example of the difference between the Green Sahara and the current Sahara. Today, Lake Chad is a relatively small and very shallow lake at the edge of the Sahel, reduced to a fraction of its recent historical extent by water overexploitation and climate change. But during the African Humid Period, Lake Chad was Megachad, an inland lake of extraordinary dimensions covering approximately 400,000 square kilometers, larger than the current Caspian Sea, which is the largest lake in the world today. That inland lake, whose ancient shores are still visible as fossil coastlines in the current Sahelian landscape, was the hydraulic heart of the Green Sahara, the collector that received the waters of rivers flowing from north and south toward the center of the continent. The Wadi Hawar, The ancient river that connected the mountains of Chad to the Nile between 10 and 5,000 years ago was at its peak one of Africa's major rivers, comparable in size to the current Senegal or Volta rivers. Along its banks lay the settlements of the Eastern Saharan pastoralists, and the archaeological records of those settlements show an economic and social life of considerable complexity. The pottery produced in those settlements, the personal ornaments found in their burials, and the exchange artifacts from distant regions all point to a desert civilization that was far from simple or primitive. The evidence of that ancient Saharan hydrology is also visible in the underground drainage systems. Beneath the sands of the current Sahara exist enormous fossil water aquifers, water that accumulated in the porous subsurface sediments during the African Humid Period and that has since remained trapped there, without recharge, because the rains that filled them have disappeared. That fossil water, from which some Sahelian countries today extract millions of cubic meters for irrigation and human consumption, is a direct legacy of the Green Sahara, a millennial water reserve that is being depleted without possibility of renewal under current climate conditions. The human beings who lived in the Green Sahara during the African Humid Period are one of the most fascinating and least known prehistoric populations in human history. The evidence of their presence is everywhere in the current Sahara. Napped stone artifacts, camp remains, burials, and above all rock paintings and engravings covering the walls of caves and rock shelters throughout the Sahara. That rock art tradition, extending over thousands of years and documenting the fauna, human activities, and possibly the beliefs of the Green Saharan populations, is one of the most extensive and richest cultural records of the African Paleolithic and Neolithic. The rock art of the Sahara shows not only the fauna and economy of the Green Saharan populations, but also aspects of their social and spiritual life. Some of the most enigmatic figures, particularly from the Roundheads period of the Tassili, represent hybrid beings, part human and part animal, or human figures with ornaments and postures suggesting ritual or shamanic contexts. Those figures, which some researchers interpret as representations of altered states of consciousness or spiritual beings, are comparable to shamanic art from other prehistoric traditions and suggest that the Green Saharan populations had a religious and symbolic life of some complexity. The Gabbaro burials also provide evidence of the violence that existed in the Green Sahara alongside the abundance. Some individuals show healed injuries consistent with interpersonal violence, and at least one shows evidence of an unhealed violent injury that may have caused death. Competition over access to water sources and pasture, the universal sources of conflict in pastoral societies, would have operated in the Green Sahara as they operate in pastoral societies today. The network of exchange that connected the different regions of the Green Sahara during the African Humid Period is also visible in the distribution of specific types of stone tools across the Sahara. Particular knapping styles and tool forms that originated in specific regions spread across the entire Sahara during the Humid Period, carried by the movement of people and ideas across a continent that was traversable in ways it has not been since. Those stylistic connections, traceable across thousands of kilometers, are the archaeological signature of a connected world that the desert has since divided into isolated fragments. The pottery traditions of the Green Saharan populations are also an important source of information about their lives and cultural connections. The wavy line pottery tradition, characterized by decorative patterns of wavy lines pressed into the clay with a serrated tool, appears across an enormous area of the Sahara and Sahel from approximately 10,000 to 6,000 years ago. That wide distribution of a distinctive ceramic tradition is evidence of the cultural connections that existed across the Green Sahara during the African Humid Period, and possibly of the movement of actual people or ideas across those distances. The transition from hunting and gathering toward herding was also accompanied by significant social changes that the archaeological record documents in the Green Sahara. Herding communities required different social structures than hunting ones. The management of cattle herds across large territories required coordination between families, systems for resolving conflicts over access to water and pasture, and mechanisms for sharing resources during periods of local scarcity. The complexity of those social arrangements, visible in the archaeological record of the late Green Saharan sites, prefigured the more elaborate social organizations that would emerge in the Nile Valley and elsewhere once the conditions of abundance that sustained them in the desert had been replaced by the concentrated productivity of river agriculture. The Gabbero site in southern Niger, described as the largest prehistoric cemetery in the Sahara, has provided not only genetic and archaeological data but also information about the health and diet of the green Saharan populations. Analyses of the bones of individuals buried at Gabbero show their diet was rich in animal protein, consistent with an economy based on fishing and herding, and that their health in general was comparable to that of other prehistoric populations in equally productive environments. They were not people living under conditions of extreme precariousness. They lived in a world that provided them with the resources necessary for a relatively good life, until that world disappeared. The animals buried with their owners at Gabbero are also first-rate information about the relationship between green Saharan populations and the animals with which they coexisted. Dogs buried alongside people in embracing positions, with the animals' legs placed over the humans, suggest a level of affection and symbolism in the person-animal relationship that would have been completely familiar to any modern person. Those burials are also some of the oldest known examples of dogs as companion animals in human history, which adds another dimension to the story of the Green Sahara as a place of cultural innovations with global reach. The ancient DNA analyses of green Saharan human remains are revealing surprising genetic connections with populations from very distant regions. Some individuals found at Moroccan and Algerian Saharan sites from between 8 and 6,000 years ago show genetic affinities with Levantine Mediterranean populations, suggesting that the movement routes of people during the African Humid Period connected North Africa with the Near East in ways that the current desert geography makes difficult to imagine. Others from Central Saharan sites show affinities with Sub-Saharan African populations, reflecting the northward movements that the Saharan regreening would have facilitated. The transition from hunting and gathering toward animal husbandry was especially important in the Green Sahara. Archaeological records show that domestic cattle, bovines, were present in the Sahara between 8 and 9,000 years ago, and that in the following centuries and millennia herding became the dominant way of life of the populations of the Central and Northern Sahara. Those herder populations were mobile groups that followed the seasonal rain cycles with their herds, camping beside lakes and rivers in the dry season and moving toward richer pastures when the rains arrived. The connection between the Green Sahara and the origin of Egyptian civilization is one of the most fascinating hypotheses in African prehistory, and one of those with the most archaeological support. When the desert began returning between 7 and 5,000 years ago, the populations of the Green Sahara faced an existential choice: adapt, migrate, or die. The regions of the Sahara that dried most rapidly were abandoned first, and their inhabitants moved toward zones where conditions still allowed survival. Groups from the northern Sahara moved northward toward the Mediterranean. Those from the central Sahara moved south toward the Sahel, and those from the eastern Sahara moved east toward the Nile Valley. The Nabta Playa site in southwestern Egypt is one of the most remarkable archaeological sites in the entire Saharan region. Located in what is now a barren desert depression, it was during the African Humid Period a seasonal lake that attracted herding communities during the dry season when the lake's water was the only reliable source for their cattle. The site contains stone circles and megalithic alignments that some researchers interpret as astronomical markers, predating Stonehenge by several thousand years, as well as cattle burials and evidence of elaborate ritual practices associated with herding. The connection between the Saharan populations and the early Nile Valley cultures has also been investigated through cattle genetics. The domestic cattle in the earliest Egyptian archaeological sites show genetic characteristics connecting them to the African cattle breeds herded in the Sahel for thousands of years, which are distinct from the Near Eastern cattle that accompanied the spread of agriculture from the Fertile Crescent. That genetic signature is consistent with the hypothesis that early Egyptian herding came from the Saharan West rather than from the agricultural East. The pharaonic Egyptian calendar, which divided the year into 3 seasons corresponding to the flooding, the growing, and the harvesting of the Nile, may also reflect the heritage of the Saharan pastoral calendar that preceded it. The herding peoples of the Green Sahara would have organized their movements and activities around the annual cycle of the monsoon rains, the growth of pastures, and the dry season retreat to the permanent water sources. That seasonal structure, transplanted to the Nile Valley, could have provided the template for the agricultural calendar that the Egyptians developed as they learned to farm the Nile floodplain. The relationship between the end of the Green Sahara and the beginning of the Bronze Age in the Mediterranean is also an active area of research. The Bronze Age civilizations of the Eastern Mediterranean, including the Minoan, the Mycenaean, and the early Levantine cultures, emerged approximately 4,000 to 3,000 years ago, broadly contemporaneous with the final phases of Saharan desertification. Whether the demographic pressures and economic disruptions produced by the African Humid Period ending contributed to the conditions that fostered the rise of Bronze Age complexity is a question that archaeologists and climate historians are beginning to address with the new tools of paleogenomics and paleoclimatology. The Nabta Playa megalithic structures, predating Stonehenge by several thousand years, are also relevant for understanding the intellectual achievements of the Green Saharan populations. The ability to construct a monument aligned to the summer solstice, as some of the Nabta Playa structures appear to be, requires sustained astronomical observation over many years, a social organization capable of coordinating communal labor, and a conceptual framework that connects the movements of the sky to the cycles of the seasons and the needs of the herds. Those capacities, developed in the context of Saharan herding culture, were the intellectual precursors of the astronomical achievements of pharaonic Egypt. Those ritual practices associated with cattle in the late Green Sahara are also relevant for understanding the role of cattle in ancient Egyptian religion and culture. The sacred bull Apis, the cow goddess Hathor, and the numerous other bovine divinities of the Egyptian pantheon reflect a deep cultural relationship between the Egyptian people and cattle that goes back long before the historical period. The origins of that relationship likely lie in the herding cultures of the Green Sahara, where cattle were not merely an economic resource but objects of ritual attention and possibly of religious veneration, as they are in many pastoral cultures in Africa today. The Nile Valley at that time was an extraordinary refuge. While the desert was spreading across all of North Africa, the Nile kept flowing, fed by the rains of equatorial African sources that the Saharan desertification had not reached. The annual Nile floods deposited layers of fertile silt on the riverbanks, creating a narrow band of extraordinarily productive land in the middle of the advancing desert. The Badarian culture that flourished in Upper Egypt between approximately 6,500 and 5,500 years ago is considered by many archaeologists as the link between the late Green Saharan cultures and the pre-dynastic Egyptian culture that would lead to the unification of pharaonic Egypt approximately 5,000 years ago. The characteristics of Badarian pottery, its personal ornaments, and its funerary practices show influences from the Western Saharan cultures that the archaeological records document in the immediately preceding period. The funerary rite of burying the dead oriented toward the west, which is characteristic of the Badarian culture and several subsequent pre-dynastic Egyptian cultures, could also be an echo of the geography of the world from which the Saharan refugees came. The west was the direction from which they came, the direction of the world they had lost. And orienting the dead toward the west could be a way of pointing the way back to the land of the ancestors that the desert had claimed. The animals of the Green Sahara also left their mark on the religious beliefs of the Egyptians. The gods of ancient Egypt include figures with the heads of animals that are characteristic of the Green Saharan ecosystems. Sobek, the crocodile god, Tauret, the hippopotamus goddess, and Set, whose sacred animal has been identified with different Saharan animals. Those religious associations with animals that no longer existed in the historical Egypt of the Nile Valley could be cultural echoes of the era when those animals lived in the territories of the Egyptian ancestors in the Green Sahara that lay to the west of the Nile. The question of why the Green Sahara ended, and why it did so with apparent rapidity, is one of the most actively investigated in modern paleoclimatology. The ultimate cause of the end of the African Humid Period is the same as its initial cause, the Milankovitch cycles. In the same way that the precession of the Earth's axis had intensified the African monsoon 11,000 years ago by making northern hemisphere summers hotter, the continuation of that precession in the opposite direction was gradually reducing the intensity of northern hemisphere summers, cooling the African continent relative to the surrounding oceans, and weakening the monsoon. The models that reproduce the abrupt transition from the green Sahara to the arid Sahara are also teaching climate scientists something important about the nature of tipping points in the Earth system. The Saharan system appears to have at least two stable states: the moist vegetated state and the arid unvegetated state. Transitions between those states are not smooth and proportional to the forcing that drives them, but abrupt and potentially irreversible on human timescales, because the feedbacks that maintain each state also resist the transition to the other state. The same feedback mechanism that produced the abrupt end of the green Sahara is also relevant for understanding the sudden expansion of the Saharan sand dunes at the end of the African Humid Period. When the vegetation cover crossed below the threshold needed to stabilize the surface, the sands locked under the vegetation were freed by the wind. That cascade of sand mobilization contributed to the suddenness of the transition in some regions, accelerating the desertification beyond what the monsoon weakening alone would have produced. The Saharan transition also provides a natural experiment for testing the theories of landscape ecology about the relationship between ecosystem resilience and diversity. The green Saharan ecosystem, with its diverse mosaic of grasslands, woodlands, wetlands, and aquatic habitats, was presumably more resilient to climatic fluctuations than the arid ecosystem that replaced it, because the diverse mosaic provided more refuges and more pathways for recovery after disturbances. The collapse of that diverse mosaic into a single arid state as the monsoon weakened represents the crossing of an ecological threshold that the paleological record documents in unprecedented detail. The Saharan dust that leaves Africa today does so primarily through two pathways: a northern path across the Mediterranean to Europe and the Middle East, and a western path across the Atlantic to the Americas. During the African Humid Period, when the Sahara was vegetated and less dust was available for transport, both of those pathways carried significantly less dust. The Mediterranean and the Atlantic were cleaner, the Amazon received less phosphorus, and the global dust cycle was different in ways that affected ecosystems and climate across the northern hemisphere. The greening of the Sahara was not just an African event, it had planetary consequences. That insight, that the Earth's climate system contains tipping points where small additional forcing can trigger large abrupt transitions, is one of the most important messages that the study of the green Sahara has contributed to the science of climate change. The same logic applies to other components of the Earth system. The Greenland and Antarctic ice sheets, the Amazon rainforest, the circulation patterns of the Atlantic Ocean, and several other systems have been identified as potential tipping points that could undergo abrupt transitions under climate forcing. Understanding the dynamics of the Saharan tipping point, which has already been observed and documented in detail, provides a template for thinking about those other potential transitions. The comparison between the abrupt end of the green Sahara and the possibility of abrupt transitions in the current climate system is not meant to be alarmist. The Saharan transition was driven by natural orbital forcing that operated over centuries to millennia. The current climate forcing from greenhouse gases is much faster, but the feedbacks that could amplify it into abrupt transitions are the same kinds of feedbacks that operated in the Saharan case. That parallel is informative about the types of dynamics that are possible, without predicting specific outcomes. The explanation of that apparent contradiction between a gradual orbital forcing and an abrupt climatic response lies in the feedback mechanisms. The same positive feedback cycles that amplified the start of the African Humid Period, the relationship between vegetation, local humidity, and rainfall, are also responsible for its abrupt end. When the weakening monsoon reduces rainfall below a certain threshold, the vegetation begins to die. And when the vegetation dies, the soil surface stops absorbing solar energy and starts reflecting it, reducing the local warming that attracted the moist ocean winds. The climate models that have tried to reproduce the transition from the green Sahara to the arid Sahara have had to include those vegetation-climate feedbacks to reproduce the observed speed of change. When the models only include the orbital forcing, they produce gradual transitions that do not match what the sedimentary records show. When they include the vegetation albedo rainfall feedback, they produce more abrupt transitions that more closely resemble what the data indicates. The monsoon also interacts with vegetation through another fundamental mechanism besides albedo: evapotranspiration, the process by which plants release water vapor to the atmosphere through their leaves and the soil surface. The green Saharan vegetation would have transpired large quantities of water vapor into the atmosphere, increasing air humidity and favoring the formation of convective clouds that would produce additional rainfall. That mechanism, the so-called recycled rainfall, in which the water evapotranspired by vegetation falls again as rain in the same region, could have contributed very significantly to maintaining the African humid period for longer and with more intensity than the orbital forcing alone would have been able to sustain in the absence of those biological feedbacks. The Saharan dust, that is paradoxically one of the most important resources for Atlantic and Amazonian ecosystems, also connects the current Sahara to the living world that replaced the world it lost. Saharan dust transported by winds westward over the Atlantic carries minerals, especially phosphorus, that fertilize the surface waters of the tropical Atlantic and contribute to the productivity of marine ecosystems. And a portion of that dust reaches the Amazon, where the phosphorus it contains is a key limiting nutrient for tropical forests growing in relatively phosphorus-poor soils. The current arid Sahara, which appears a purely local system, is in reality an integral component of the ecosystems of the western half of the world. The desertification of the Sahara did not affect all regions of the African continent equally. While North Africa was becoming the desert we know today, the ecosystems of equatorial and southern Africa remained relatively stable, and the Sahel regions compressed southward but did not disappear. The dispersal of the Proto-Nilo-Saharan language family, which is the ancestral language of many of the peoples currently living in the Sahel and East Africa, including the Nilotic peoples of South Sudan, Uganda, and Kenya, is also possibly connected to the movements produced by the desertification of the Sahara. Linguists situate the homeland of Proto-Nilo-Saharan somewhere in the eastern Sahara or the Nile Valley region, and its dispersal southward and eastward during the period when the Sahara was drying would have followed the same corridors that the archaeological evidence shows the human populations using. The hippos of the Green Sahara are one of its most surprising inhabitants for modern observers. Hippopotamuses require permanent large water bodies to survive, spending most of the day submerged. Their presence in the Sahara during the African Humid Period is one of the most direct proofs that those large permanent rivers and lakes actually existed. The rock paintings and fossil bones showing hippos in regions that today receive less than 10 millimeters of rain per year are among the most dramatic evidence of how completely the Saharan environment has changed. The African Humid Period also had a significant impact on the fauna of the Mediterranean islands. Archaeological and paleontological records from Sardinia, Sicily, Malta, and other Mediterranean islands show that during the humid period, several African species, including hippopotamuses and other large mammals, were present on those islands, having presumably crossed when sea levels were lower and island connections were more numerous. The subsequent isolation and extinction of those island faunas as the Mediterranean became drier and sea levels changed is another chapter in the story of how the African Humid Period shaped the biodiversity of a vast region. The North African lion was one of the largest subspecies of lion that ever existed, with males reaching weights of over 250 kilograms and characteristic dark manes extending onto the belly. It survived in the Atlas Mountains of Morocco and Algeria until the late 19th century, with the last confirmed wild individuals killed in the 1890s. The captive descendants of the last North African lions are maintained in zoos in Morocco and other countries as a living connection to the fauna of the Green Saharan Age. That population, subject of ongoing genetic research, is a small and fragile remnant of the rich megafauna that once roamed from the Atlantic coast to the Nile. The story of the Saharan fauna is also a story about the connections between Africa and the Mediterranean. Several species that lived in the Green Sahara, including the elephant, the lion, and the spotted hyena, were also present in North Africa and the Mediterranean islands in historical times, and their elimination from those regions was partly the result of the progressive aridification that followed the African Humid Period and partly the result of human hunting. The Barbary lion, the last North African lion, was hunted to extinction in the wild in the 20th century. The North African elephant, which the Carthaginians used in their wars against Rome, was eliminated by hunting and habitat loss during the historical period. Those extinctions are the last chapter of a story that began when the Green Sahara dried and the large fauna of North Africa found itself in a shrinking and increasingly fragmented world. That geographical inequality in the impact of desertification had important consequences for the distribution of human populations on the continent. The Saharan populations that emigrated southward as the monsoon retreated did not arrive in empty territories. They arrived in territories where other human groups already lived. That demographic push from north to south, produced by desertification, contributed to mixing populations that had previously been more geographically separated and may have accelerated the diffusion of cultural and technological innovations, including animal husbandry and eventually agriculture, towards sub-Saharan Africa. The history of the Saharan fauna is also a history of extinctions. Many of the animals that lived in the Sahara during the African Humid Period and that are represented in the rock paintings of the region disappeared, either from that specific region or from the entire planet, when the desert returned. The Pelorovis antiquus, the giant long-horned buffalo whose imposing images appear in the rock paintings of the Tassili and other Saharan sites, went extinct approximately 12,000 years ago in North Africa, probably as a combined result of human hunting pressure and the recession of its habitat as the Sahara aridified. The rock art of the pastoral period of the Tassili, with its detailed representations of cattle in motion, crossing rivers, being milked and being cared for by herders, is also one of the richest records of prehistoric herding anywhere in the world. Those paintings are not simply static representations of animals, but scenes of daily life that capture the relationship between herders and their herds with a vitality and realism that many modern artists would find difficult to equal. They are, in that sense, not only archaeological data but also works of art that deserve to be contemplated in their own terms. The animals of the extinct Saharan fauna are represented not only in rock art. Their fossil and subfossil remains are found in the sediments of lakes and river basins across the Sahara. Those remains, dated with radiocarbon and thermoluminescence techniques, confirm that the animals represented in the rock art really did live in those regions at the dates the paintings suggest. The coincidence between the artistic evidence and the fossil evidence is one of the most direct confirmations that the rock art of the Sahara faithfully represents the world its creators knew, not imaginary worlds or mythological figures. The crocodiles also lived in the Green Sahara, and in fact still live in it today, though in very reduced numbers and in very specific locations. In the mountain massifs of the Central Sahara, in permanent water pools fed by springs from the fossil groundwater of the African Humid Period, small populations of Nile crocodiles survive that are the last descendants of the large populations that inhabited the rivers and lakes of the Green Sahara 8 or 10,000 years ago. Those Saharan crocodiles, discovered by European explorers in the early 20th century and studied ever since, are a living biological vestige of the world that was. The rock paintings of the Green Sahara are, in addition to an archaeological record, a form of art of notable beauty and vitality that deserve to be contemplated in their own terms, independently of the scientific information they contain. The Tassili Eniger landscape itself is a place of extraordinary geological and aesthetic beauty that deserves to be appreciated independently of its rock art. The sandstone plateaus, known as Tassili in the Tuareg language, are ancient sedimentary formations that have been sculpted by millennia of wind erosion into a landscape of dramatic arches, columns, and canyons. The rock surfaces that carry the paintings are the same surfaces that the ancient populations inhabited and sheltered in, and the paintings are embedded in a landscape that has its own visual power before any human mark is added. The round-headed figures of the tassali, one of the most enigmatic art traditions of the prehistoric world, have been interpreted in many different ways. Their abstracted, almost alien appearance, with large oval heads and featureless faces, has led some researchers to suggest they might represent beings wearing ceremonial masks, others to suggest they represent spirits or deities, and still others to propose explanations related to specific painting techniques. The mystery of those figures, unresolved after decades of study, adds to the sense that the Green Sahara harbored a rich inner life that the rock art only partially reveals. The study of the rock art of the Sahara has also transformed our understanding of the cognitive and artistic capabilities of the prehistoric populations of Africa. For many decades, the dominant narrative of prehistoric art placed its origins in Upper Paleolithic Europe, with the cave paintings of Altamira and Lascaux as the first flowering of full artistic capacity. The extraordinary richness and antiquity of African rock art, including the Saharan tradition, has displaced that Eurocentric narrative and demonstrated that artistic expression was a pan-human capacity that flourished in Africa as richly and as early as anywhere else in the world. The visitors who reach the tassali today, after the long and difficult journey through the Saharan desert, describe the experience of entering the painted landscape as entering another time. The sandstone architecture of the plateaus, sculpted by wind into forms that resemble ruined cities, creates a setting that amplifies the strangeness of the paintings on the walls. The figures looking out from those ancient surfaces were painted by people who lived in a world that is now gone, in a landscape that is now unrecognizable. And yet the paintings survive, more durable than the civilization that produced them, more durable than the ecosystem that sustained that civilization. The researchers who have spent careers studying the Saharan rock art describe the experience of encountering those paintings in their setting as one of the most moving in their professional lives. Standing in front of a painted rock wall in the tassali, with the desert stretching to every horizon and the silence broken only by the wind, and seeing the image of a hippopotamus swimming painted by a hand that lived 10,000 years ago, that experience compresses time in a way that no museum exhibition can replicate. The painting is not a reproduction or a document. It is the original act, still present in the place where it was made, waiting to be seen again. The international scientific community working on the Green Sahara also includes a growing number of African researchers, particularly from the countries of the Saharan and Sahelian regions where the sites are located. That growing African participation in the research is not only equitable but also scientifically valuable. Researchers who have grown up in the region, who know the landscape and the languages of the communities living in it, and who have their own cultural connections to the history of the Sahara, bring perspectives and knowledge that researchers from outside the region cannot provide. The Tassili Enajur in southern Algeria is perhaps the most extensive and most impressive rock art site in the world. With approximately 15,000 engravings and paintings in an area of 72,000 square kilometers of sandstone plateaus and canyons, the Tassili is an open-air museum of the history of the Sahara during the last 10,000 years. The images cover several stylistic periods that researchers have identified and dated with some precision. The period of the Bubalus, named for representations of an extinct buffalo, the period of the round heads, with their stylized, almost extraterrestrial-looking human figures, the pastoral period, with its detailed representations of cattle and herder activities, and the period of horses and camels, which document the arrival of those animals in the Sahara as the desert consolidated. The international legal protection of Saharan rock art has also progressed significantly in recent decades, with several of the most important sites declared UNESCO World Heritage Sites. The Tassili Enajur in Algeria was declared a World Heritage Site in 1982, both for its natural values and its rock art. That international recognition has contributed to raising awareness about the importance of the site and to mobilizing resources for its protection and study, though the resources continue to be insufficient for the scale of the work needed. The conservation of Saharan rock art is also an urgent challenge. Although the arid desert conditions have preserved for millennia paintings that in more humid environments would have disappeared long ago, the rock art of the Sahara faces today threats from various sources. Uncontrolled tourism that brings visitors into physical contact with the paintings, deliberate vandalism, armed conflicts in some regions, and the action of wind and sand eroding the surfaces on which the images are painted. The photographic and digital documentation of that heritage, before conditions destroy it, is a race against time. The color of the pigments used in Saharan rock art also provides indirect information about the origin and composition of those paintings. Red ochre produced from iron oxides and black manganese are the most common pigments, but some sites also show the use of white kaolin and more complex colored ochres produced by mixing minerals of different origins. Identifying the geological source of those minerals through isotopic composition analysis can reveal the movement territory of the groups that produce the paintings and provide information about the raw material exchange networks that connected different parts of the Green Sahara. The documentation of Saharan rock art through digital technologies is also being transformed by hyperspectral imaging, which captures information about the terrestrial surface in dozens or hundreds of wavelength bands simultaneously. That technique can detect subtle differences in the chemical composition of the surface that are invisible to conventional imaging systems, including faded paintings that have lost enough pigment to be imperceptible to the naked eye. Those recovered images are adding new figures and scenes to the already extraordinarily rich catalog of Saharan rock art. The Green Sahara was not only an African phenomenon. Its effects extended far beyond the continent's borders and connected the history of the Sahara with the history of the Mediterranean, the Middle East, and much of the ancient world. The Sahara as a geographic concept is also being reconsidered in light of the Green Sahara research. What we call the Sahara today, the largest non-polar desert on Earth, is not a permanent feature of the African geography but a climate state that has been present for approximately 5,000 years, with intermittent wetter periods over the last 100,000 years. Before the African Humid Period, there were other humid periods, and before those, other arid periods going back through the Pleistocene ice ages. The Sahara as we know it is the current expression of an oscillating climate system that has produced very different landscapes in the same geography at different times. The history of exploration of the Saharan rock art is also a story of how indigenous knowledge guided the researchers who eventually documented those sites systematically. The Tuareg, the Tubu, and other peoples of the Saharan margin had known about the rock paintings for generations before European explorers encountered them. The first European scientific descriptions of Saharan rock art in the 19th century were made possible by guides from those communities who knew where the paintings were and could navigate the desert safely. The connections between the Green Sahara and the civilizations of the ancient Mediterranean extend also to the Phoenicians and the Carthaginians, who established trading cities along the North African coast and penetrated into the Saharan interior in search of gold, ivory, and slaves. Those trade routes followed the geography of the dying Green Sahara, using the residual oases and water sources that persisted after the main humid period had ended. The Saharan trade routes of antiquity, which would eventually be formalized by the camel caravans of the Islamic period, trace the ghost of the Green Saharan landscape in their paths through the desert. The cultural legacy of the Green Sahara is also visible in the oral traditions of the peoples who live in the Saharan and Sahelian margins today. Many of those traditions contain references to a time when the desert was different, when water was abundant, when the ancestors lived in places that are now uninhabitable. Those oral memories, transmitted across dozens of generations, are the human equivalent of the sedimentary record, imprecise and transformed by the passage of time, but carrying within them a kernel of historical experience that the science is beginning to verify and contextualize. The Saharan trade networks that connected sub-Saharan Africa to the Mediterranean during the historical period also cast their shadow back onto the Green Saharan period. The gold, ivory, and other resources that the Saharan caravans of antiquity carried northward were produced in the same West African and Central African regions that had been connected to the North African populations of the Green Sahara by the routes across the humid continent. The trade networks of the Green Sahara, visible archaeologically as the distribution of exotic materials across the ancient sites, were the ancestors of the historical trade networks that connected the ancient Mediterranean world to sub-Saharan Africa. That longer perspective also changes how we think about the populations currently living on the margins of the Sahara and Sahel. The Tuareg, the Tubu, the Fulani, the Hausa, and the many other peoples of the Saharan and Sahelian margin are the cultural descendants of the populations who inhabited the Green Sahara and adapted to the advancing desert over 5,000 years. Their knowledge of the desert, their herding practices, their water management traditions, and their relationships with the land are not simply survival skills, but the accumulated product of 5 millennia of living at the edge of a climate transition. That knowledge, increasingly recognized as valuable by climate scientists and development practitioners, is part of the human heritage of the Green Sahara that continues into the present. One of the most important effects of the African Humid Period in extra-Saharan regions was the increase in the level of African rivers that empty into the Mediterranean. The Nile, whose basin includes parts of what is today the Sahara, carried during the African Humid Period considerably greater water volumes than current levels, producing more extensive annual floods that deposited more fertile sediment on the alluvial plains of the delta. That greater fertility of the Nile Valley during the peak of the African Humid Period could have been one of the factors that allowed the development of early agriculture in Egypt and eventually the appearance of ancient Egyptian civilization. The Sahara also acted as a climate barrier in reverse during its green periods. It acted as a corridor that connected North Africa with sub-Saharan Africa. That alternation between barrier and corridor, controlled by climate cycles, largely determines the history of cultural and biological connections between the two halves of Africa and between the Mediterranean and tropical Africa. African history is, in many respects, the history of that door that opens and closes with the climate. The dispersal of Proto-Afroasiatic speakers, the common ancestor of one of the most diverse language families in the world, which includes Arabic, Hebrew, Ethiopian Amharic, Berber, and Chadic, is also possibly an indirect consequence of the Saharan desertification. Linguists place the original homeland of Proto-Afroasiatic somewhere in North or Northeast Africa between 10 and 8,000 years ago, precisely during or shortly after the peak of the African Humid Period. The subsequent dispersal of that language family across North Africa and the Middle East could reflect the population movements that the advancing desert was forcing from the interior of the Sahara toward its margins. The connection between the end of the Green Sahara and the beginning of writing is also striking, though difficult to prove causally. The first known writings of humanity, Sumerian cuneiform and Egyptian hieroglyphics, appear approximately between 5,000 and 4,500 years ago, precisely the period when Saharan desertification was in its most intense phase. The need to coordinate resource distribution under conditions of greater scarcity and demographic pressure, which the arrival of Saharan refugees in the Nile and Tigris-Euphrates valleys would have produced, could have been one of the factors driving the development of more sophisticated record-keeping systems that eventually evolved into writing. The Atlantic Ocean currents also play a role in the story of the Green Sahara. Studies of those currents have revealed connections between the intensity of the African monsoon and the temperature of the tropical Atlantic surface waters off the West African coasts. When the tropical Atlantic is warmer, the temperature difference between the ocean and the African continent decreases, weakening the monsoon. When it is cooler, that difference increases and the monsoon intensifies. Those variations in tropical Atlantic temperature, controlled in turn by the ocean currents that distribute heat through the oceans, add an additional layer of complexity to the Green Sahara story. Modern research on the Green Sahara is being revolutionized by technologies that barely 2 decades ago either did not exist or were not accessible to researchers. Synthetic aperture radar, a remote sensing system that uses radio waves instead of visible light to map the Earth's surface, has been especially transformative for the study of the Sahara. Unlike visible light, which can only see the surface, the right type of radar waves can penetrate several meters into the dry Saharan sand and see the rocks and sediments beneath. When researchers applied that technology to the Sahara in the 1980s, they found something extraordinary. Beneath the sands of the desert, in regions where today there is no trace of water at the surface, there is an extensive network of fossil river channels corresponding to the rivers that flowed during the African Humid Period. The luminescence dating technique mentioned earlier is also being applied to the dating of the dune fields of the Sahara, providing a chronology of when the major ergs, the great sand seas of the Sahara, formed and expanded. Those dates show that the current configuration of Saharan dune fields is largely a product of the last 5,000 years, since the end of the African Humid Period, when the remobilized sands that the vegetation had stabilized began moving again. Before that, many of the regions that are now covered by dunes were stabilized sand surfaces or exposed rock platforms. The current Saharan landscape is, in that sense, a relatively recent creation, only 5,000 years old, built from materials that have been present much longer. The carbon stored in the soils that developed during the African Humid Period is also a legacy that is only now beginning to be quantified. When the vegetation died as the desert returned, some of the organic carbon accumulated in the soils was buried and preserved in the sediments. That buried carbon represents a net carbon sink effect of the African Humid Period that has implications for understanding the global carbon cycle during the Holocene. Quantifying how much carbon the Green Sahara stored and how much was released during its collapse is an active area of research. The discovery of ancient pollen grains in Saharan lake sediments has also revealed the composition of the vegetation communities of the Green Sahara in remarkable detail. Different pollen types preserve differently in sediments, but the relative abundances of grass pollen, tree pollen, and aquatic plant pollen across different time periods tell a story of changing vegetation that complements the macroscopic fossil evidence of animals and human artifacts. Those pollen records show that the green Saharan vegetation was not static but changed continuously in response to regional climate variations, with tree cover expanding in wetter periods and contracting in drier ones. The pollen analysis of sediments from Saharan lake beds has also revealed that the vegetation of the Green Sahara was not simply a southward extension of the vegetation that exists today in the Sahel. It included plant communities with no modern analog, combinations of species that do not coexist anywhere today, reflecting climate conditions during the African Humid Period that were genuinely different from those of any current region. Those no-analog vegetation communities are a reminder that the past was not simply a rearrangement of the present but sometimes a genuinely different state of the Earth system. The connection between Saharan dust export and the productivity of the Amazon rainforest is also a vivid illustration of the planetary scale of the Saharan system. The Amazon receives approximately 22,000 tons of phosphorus per year from Saharan dust, an amount that significantly contributes to the fertility of one of the most productive terrestrial ecosystems on Earth. That phosphorus connection means that the Green Sahara, when it existed, was exporting much less dust and therefore much less phosphorus to the Amazon, which may have reduced the fertility of the Amazon forests of that period. Conversely, the regreening of the Sahara in the future, whether natural or assisted, could reduce the dust export that currently fertilizes the Amazon, with potentially significant effects on Amazonian productivity. Those fossil rivers of the Sahara, visible in radar images as dark traces under the pale sand, connect regions that today are separated by hundreds of kilometers of desert. The most important of them, the Wadi Hawar, which flowed from the mountains of Chad to the Nile between 10 and 5,000 years ago, had at its peak a length comparable to the European Rhine and fed a drainage basin that is today completely dry. The satellite observation program is also being used to monitor the advances and retreats of the desert frontier in the Sahel with a precision that ground observations could never provide. Those satellite data show that the desert frontier is not a static line but a dynamic transition zone that advances or retreats several kilometers per year depending on each season's precipitation. Understanding that frontier dynamic is fundamental for designing restoration interventions, which must adapt to a moving frontier rather than work against a fixed barrier. The satellite observation data also shows that Sahelian vegetation cover has measurably increased since the 1980s, reversing part of the degradation produced by the great droughts of the 70s and 80s. That greening, documented from space, is the most direct evidence that the feedback mechanisms that the African Humid Period also used are operating in the current Sahel, though at a much more modest scale. The paleogenomics is another of the technologies transforming the understanding of the Green Sahara. Ancient DNA analyses of green Saharan human remains are revealing that the populations that inhabited that region during the African Humid Period had a genetic composition different from that of the populations inhabiting North Africa today. That indicates that desertification produced not only population movements out of the Sahara, but also the subsequent arrival of new populations in North Africa, once the desert had consolidated and conditions had changed. The genetic history of North Africa is not that of a group that remained stable over time, but of multiple population layers that succeeded and mixed each other as climatic conditions changed. The story of the Green Sahara also has dimensions that connect directly to the challenges of the present and the near future. The Sahel, the transition region between the Sahara and the humid tropical savannas, is today one of the world's regions most affected by progressive desertification and demographic pressure. The historical memory of the African Humid Period is relevant for understanding the vulnerability of that region and the possibilities of its recovery. The fossil Saharan aquifers mentioned earlier are exploited today as water sources for irrigation in Libya, Algeria, Niger, Chad, and other countries. But that exploitation is fundamentally unsustainable because it extracts water that is not being replenished under current climate conditions. The story of the Green Sahara also connects to the story of human population growth and the carrying capacity of different environments. The African Humid Period supported much larger human populations in the Sahara and Sahel than those regions support today, because the productivity of the ecosystem was much higher. The pastoral populations of the Green Sahara could sustain their cattle and themselves on the resources of a vast productive savanna. When those resources contracted as the desert advanced, the carrying capacity of the land contracted with them, forcing populations to either leave or reduce their numbers to match the reduced productivity of the remaining habitable zones. The Great Green Wall Project is also generating new scientific data about the conditions required for vegetation to establish successfully in arid environments. Different plant species, planting techniques, and water harvesting methods are being tested across hundreds of sites, and the results are being compiled into a growing database. The most successful interventions tend to be those working with existing natural regeneration rather than imposing new plantings, and that involve local communities from the beginning. Those lessons echo the dynamics of the Green Sahara itself. The most successful vegetation establishment is the kind that is self-reinforcing once it begins. The success of the Sahel restoration efforts so far also underscores the importance of local community engagement in environmental management. The communities that have achieved the most significant vegetation recovery in the Sahel are those that have been given tenure over their land and the right to manage it according to their own traditions and needs. That finding, documented by researchers studying the socio-economic dimensions of the Great Green Wall Initiative, resonates with the history of the Green Saharan communities themselves, whose sustained management of their environment for thousands of years created the knowledge base that made their survival in a challenging landscape possible. The data generated by the Great Green Wall and other Sahel restoration programs is also contributing to a better understanding of the costs and benefits of large-scale ecosystem restoration. The economic valuation of restored ecosystem services, including carbon sequestration, water retention, and the support of agricultural productivity, is showing that the long-term economic returns from restoration can exceed the costs of implementation, especially when the avoided costs of land degradation, migration, and conflict are included in the calculation. That economic case for restoration, grounded in the ecological realities that the Green Sahara illustrates, is gradually shifting the policy landscape in the affected countries. The story of the Green Sahara ends, as all the great stories of geology and prehistory end, not with an event but with a process. There was no single last day of the Green Sahara. There was only the accumulation of drier years, the progressive retreat of the lakes and rivers, the gradual thinning of the vegetation, and the slow withdrawal of the human populations toward the places where water and grass still existed. That process, drawn out over centuries, left no monument and no memory. Only the science, the sediment cores and the satellite radar and the ancient DNA can reconstruct what happened and how fast it happened. And in that reconstruction, we find not only the story of a lost world, but also a mirror for thinking about the world we are making today. That contraction in carrying capacity is a dynamic that is playing out again in the current Sahel, driven now not by natural climate change, but by the combination of climate variability, population growth, and land degradation. The Sahelian countries are among the fastest-growing populations in the world, and that population growth is placing increasing pressure on land and water resources that are themselves under stress from climate variability. Understanding the dynamics of the Green Sahara collapse provides a framework for thinking about the risks facing the Sahel today, not as a prediction of inevitable catastrophe, but as a reminder of how quickly the carrying capacity of a system can change when climate and land use pressures converge. The Great Green Wall, the reforestation and vegetation restoration project that 11 African countries are attempting to implement across the Sahel from coast to coast, is perhaps the most direct example of how the history of the Green Sahara is influencing current land management policies in Africa. The project, which aspires to create a strip of vegetation 15 kilometers wide and 8,000 kilometers long from the Atlantic Ocean to the Red Sea, is based on the same positive feedback logic that produced the Green Sahara. Establish vegetation so that that vegetation helps create the humidity conditions that allow more vegetation to grow. The story of the Green Sahara's desertification also has a dimension that looks directly at the future. The current climate change, produced by the increase of greenhouse gases in the atmosphere, is altering precipitation patterns in Africa in ways that are still difficult to predict precisely, but that are already visible in the long-term rainfall trends in the Sahel. Some climate models project a partial regreening of the Sahara if global warming intensifies the African monsoon, while others project greater aridification. The history of the Green Sahara reminds us that that balance is extremely sensitive to small changes in climate forcing, and that transitions between states can be much faster than the processes causing them suggest. The possibility that global climate change might produce conditions that facilitate a new partial regreening of the Sahara is also a factor to consider in planning restoration interventions. If global warming intensifies the African monsoon sufficiently, investments in Sahel vegetation restoration could be amplified by climate feedbacks in ways that produce results far superior to those possible under stable climate conditions. But that possibility also has its risks. If global warming produces the opposite effect and weakens the monsoon, those same feedbacks could amplify aridification rather than regreening. The study of the Green Sahara is also producing data that is directly applicable to the search for life on other planets. Mars has in its remote past evidence of a humid period in which water flowed on its surface, and the transition from that wet Mars to the current arid Mars has parallels with the transition from the Green Sahara to the arid Sahara. The feedback mechanisms that accelerated Saharan desertification, especially the albedo vegetation rainfall feedback cycle, could have analogs in the climatic evolution of Mars, and understanding one of those processes could shed light on the other. There is something profoundly disorienting about the story of the Green Sahara that goes beyond paleoclimatic data and archaeological records. The awareness that that world existed, that it was real, inhabited, alive, and that it disappeared without any historical civilization remembering it. The story of the Green Sahara also has a dimension that connects to the fundamental human experience of loss and memory. The populations who lived through the desertification of the Sahara experienced the loss of their homeland in a way that must have been as profound as any displacement in human history. The lakes where they had fished, the rivers where they had watered their cattle, the grasslands where their children had played, all of those familiar places were disappearing under the advancing sand, generation after generation, without any dramatic event marking the end, only the slow diminishment of everything that had defined the world they knew. The green Sahara that existed 8,000 years ago is as real as the desert that exists today. It is not a legend or speculation. It is documented in the sediments of extinct lakes, in the bones of the animals that lived in it, in the DNA of the human beings who inhabited it, and in the paintings those human beings left on the stone walls. It is a world as real as ours, though it no longer exists. And that lost reality, preserved in the fragments that science knows how to read, is one of the reasons why the history of the Earth is always larger and stranger than any individual imagination could invent. The end of the green Sahara is also a story about how civilizations can emerge from catastrophe. The displacement of millions of people from the dying Sahara into the Nile Valley, the Fertile Crescent, and other regions of the ancient world was one of the greatest demographic disruptions of the Holocene. And from that disruption, driven by the need to manage scarce resources among concentrated populations, emerged some of the most complex social institutions in human history. The state, the priesthood, the bureaucracy, the army, and ultimately writing itself. The green Sahara did not die quietly. It died into the birth of civilization. The stars above the Sahara tonight are the same stars that shone above the green Sahara 8,000 years ago. The Milky Way that blazes over the desert in its extraordinary clarity, unobscured by the light pollution that makes it invisible from most inhabited places, is the same Milky Way that the herders watched while their cattle slept. The constancy of the sky above the changing world below is one of the most calming thoughts that the history of the green Sahara offers. That amid all the transformation, all the loss, all the life that has come and gone on this particular piece of the earth, the sky remains as it was, patient and indifferent and beautiful. Those losses were also losses of ecological knowledge accumulated over thousands of years. The pastoralists of the green Sahara knew their landscape with an intimacy that only comes from generations of careful attention, which plants were edible and medicinal, whether reliable water sources were during the dry season, how to read the clouds and the wind to predict the coming of the rains, which routes connected the best pastures across hundreds of kilometers. That knowledge, encoded in traditions, songs, and practices transmitted from generation to generation, was disrupted by the forced migrations that the desertification produced, partially lost and partially carried to new environments where it had to be adapted to different conditions. The first written references to the Sahara, in the texts of the Egyptian pharaohs and the Greek historians like Herodotus, already describe a desert, the same desert we know today. For those civilizations, the green Sahara was already prehistory in the literal sense. It had occurred before history, before writing, before the records that humans could leave for future humans. Only the rock paintings, motionless on their stone walls for millennia, kept the testimony that that world had existed. And those paintings had no one to read them, no one to know they were more than figures in the stone. The recovery of that lost history, made possible by the modern science of paleoclimatology and desert archaeology, is itself a notable achievement. Barely 50 years ago, the African Humid Period was known only in general outline. Today we can say with considerable detail what the Sahara was like 8,000 years ago. Which animals lived in it, what type of vegetation covered it, which rivers crossed it, which populations inhabited it, and how those populations lived, organized themselves, and represented their world on the cave walls. The green Sahara that existed 8,000 years ago is as real as the desert that exists today. It is not a legend or speculation. It is documented in the sediments of extinct lakes, in the bones of the animals that lived in it, in the DNA of the human beings who inhabited it, and in the paintings those human beings left on stone walls. It is a world as real as ours, though it no longer exists. And that lost reality, preserved in the fragments that science knows how to read, is one of the reasons why the history of the Earth is always larger and stranger than any individual imagination could invent. The archaeology of the desert, the discipline that studies the cultures that lived in regions that are now arid during the periods when those regions were more habitable, faces unique challenges that make it especially difficult and especially fascinating. The remoteness of many of the most important green Saharan sites, in regions of the Central Sahara that are days of all-terrain vehicle travel from the nearest cities, without any infrastructure. The invisibility of sites distributed across millions of square kilometers that have mostly never been systematically surveyed. And the conservation challenges from wind, sand, tourism, and conflict. The history of the Green Sahara ends, like almost all the great stories of geology and prehistory, not with an event but with a silent transformation. The last lake in the Sahara to dry out had no witness to record it. The last tree to die in what is now the Great Western Erg was mourned by no one. And the last human group to abandon the interior of the Sahara did so without knowing it was the last, simply following the water toward where water still existed, as all the previous groups had done before them. The end of the world of the Green Sahara was invisible from inside. It is only visible from outside, from the distance of time and with the instruments that modern science has developed to read what the Earth keeps. Tonight we have explored the Green Sahara from its astronomical causes to its human and cultural consequences. The intensification of the African monsoon by the Milankovitch cycles, the flourishing of savanna ecosystems and inland lakes in what is today the world's most arid desert, the populations of hunters, herders, and artists who inhabited that green world for 6,000 years. The connection between the end of the Green Sahara and the origin of the first historical civilizations of Africa and the Mediterranean, and the abrupt climatic collapse that transformed the green world into desert in the space of a few centuries. What emerges from that exploration is an image of the relationship between climate and human history that has direct relevance for the present. Human beings are not passive actors in the climate. Their activities, including the extensive herding that green Saharan populations practiced for millennia, can modify the local climate in ways that affect the ecosystems on which they depend. But they are not the only actors either. The astronomical, geological, and oceanic forces that determine the Earth's climate at scales of thousands of years are orders of magnitude more powerful than any pre-industrial human activity, and determine the fate of the Green Sahara independently of what its inhabitants did. The Sahara that exists today, that sea of sand and rock under a relentless sun, is the result of forces that began acting 11,000 years ago and completed their work 5,000 years ago. But that Sahara carries within it the remains of the world that was, the fossil river channels beneath the sand, the aquifers of water that fell 8,000 years ago, the paintings on the rocks where hands that are no longer there left the image of animals that are no longer there. It is an archive of the past richer than it appears from the outside, if one knows how to read it. The parallel with the present is inevitable and must not be ignored. Today, human beings are the most powerful force operating on the Earth's climate, more powerful than the Milankovitch cycles at the timescale of the current century. The speed of the climate change we are producing far exceeds that of the natural transitions of the past, including the transition from the Green Sahara to the arid Sahara. And the human populations living in the regions that climate change is affecting have no more time to adapt than the Saharan herders had when the desert began advancing 5,000 years ago. The Green Sahara also teaches us something essential about hope and about the difference between fatalism and realism when facing environmental challenges. The same feedback mechanisms that accelerated the desertification of the Sahara can also work in reverse, amplifying the effects of vegetation restoration efforts. The Great Green Wall, the Sahel restoration projects, the satellite data showing real vegetation increase in the Sahel over recent decades. All of these are signs that the Green Sahara's lesson can be applied in the other direction. That a small change in conditions, if sustained and if the positive feedbacks are allowed to work, can transform a desert into something greener. The Green Sahara was not created by a single large event, but by the accumulation of small incremental changes that eventually crossed a threshold. The same is possible in reverse. The threshold exists in both directions. Tonight, as sleep arrives, the Sahara continues in its place. The stars that the green Saharan herders observed 8,000 years ago are the same stars shining over it tonight. The same stars that shone when the Nile received the first families arriving from the west with their cattle and their painted memories. And the same wind that for centuries was carrying sand to cover the lakes and rivers that had made that life possible continues blowing tonight, quiet, indifferent to the passing time, moving the desert grain by grain, keeping its ancient secrets in the layers below. The sand that the wind moves tonight over the Sahara was part of a lake bottom 8,000 years ago, when fish swam above it and herons waded at its edges and children played on its shore. It has traveled a long way to reach this moment. So have we. If this journey kept you company tonight, subscribe to the channel. There are many more worlds waiting to be explored in the dark.